Okay, so I want to kind of do this very strange thing where I'm going to type up the solutions to these practice problems, but while I do it, I'm going to talk through what I'm doing. Okay, and the reason that I'm going to do that is because I think it's helpful if I explain what my thought process is, but I don't have enough time to make a video and type the solutions. So this is sort of the thing that I've come up with. Maybe one good thing is that we can, it'll help you if you have questions about LaTeX and how I do things. Maybe this will help. I don't know. Or maybe you can give me pointers and be like, hey, why are you doing it that way? Don't you know there's an easier way to do this? Okay, so to begin with, I'm going to take Fourier transforms of both sides. So take transforms of both sides. As a general rule, when I'm doing something in front of people, I'm going to make all the mistakes that I ever make. I don't usually make the mistakes, but when I'm typing or coding in front of somebody, I'm going to make all of them. So you'll get to see a lot of that as well. So take Fourier transforms of both sides. Okay, so now the Fourier transform of the t derivative of u is just going to be the Fourier transform. I think I have a command for hat, so I'm going to make a command. I thought I had one. It might tell me I already have one. Okay, so the t derivative, so if I have the t derivative of u and take the Fourier transform, this is just the t derivative of the Fourier transform. And now the Fourier transform of the double x derivative is going to be minus c squared times the Fourier transform of u. So I'm going to compile. I just do control save to make it compile. I just want to make sure that I've got something. I need to come up here and do the answers. Okay, so that's what we have there. Okay, so this is a first order ODE for the Fourier transform of u. And it's just the t derivative of u is equal to minus c squared u, or the t derivative of u hat is equal to minus c squared u hat. So the general solution Fourier transform of u evaluated at ct is going to be equal to the Fourier transform of u evaluated at c0 times e to the minus c squared t. Okay, and we know, okay, so a general solution, but what is this? I know, maybe I'll talk about this separately. Okay, so what's that equal to? Well, okay, so now we're going to do the Fourier transform, but we're going to keep t is equal to 0. So this is the integral from minus infinity to positive infinity, u of x0 e to the minus I x e to the minus ixc dx. Okay, but this is just equal to, well, u of x0 is just going to be this function here, which I'm going to call, well, I'll just leave it like that for now. Okay. Actually, let me call it g of x. G of x e to the minus ix. Whoops. Ix c dx. Okay, let me make sure this is what I want it to be. Okay, well, this is just equal to the Fourier transform of g. Now we don't actually need to take the Fourier transform of g, and you'll see why in a moment. So then we've got the h derivative, the Fourier transform of u is equal to the Fourier transform of the initial condition times, where'd we go? Times this right here. So I'm just going to copy, paste it down there. Okay, now again, we know what the inverse Fourier transform of that is, and we know what the inverse Fourier transform of that is. It's just equal to this function up here that we're given. Okay, so the inverse Fourier transform of this we'll talk about in just a second. What is the inverse Fourier transform of that? It's just this function there. Okay, so that's why you don't need to take the Fourier transform, because in just a minute we're going to be doing the inverse Fourier transform. Okay. Now remember, so we talked about this in our problem session on Wednesday. So I'm going to write this in the following: hat G. So I'm going to rewrite this quantity in the exponents in the following way. Okay, so this is going to be equal, so we talked about this in the problem session on Wednesday. We're doing the inverse Fourier transform of this. Okay, so this is going to be 1 over the square root of 4 pi t times square root of 4 pi t times e to the power of minus c squared divided by, okay, here's where it gets a little messy. So now I'm definitely probably going to have a problem with the compilation. What does this go with? I need to have this over here. So this is minus c squared. Wait, I'm going to do this as frac minus c squared. And then this is going to be 4 over 4t. Okay, so now this, what I have written here, is exactly the same as what I have written here. I've just rearranged it so that I can use the entry in the Fourier transform. So I'm going to have to go to a separate line here. Okay, so now what's going to happen is this piece right here, as far as Fourier transforms are concerned, this is a constant. So I'm going to bring that out, and then I'll have all of this left. And then I need this. Okay, let me compile and see what we have. Okay, so u hat of this is equal to g hat times that. I've rearranged it here, I factored this out, and now I have this. And now I'm going to use the convolution theorem. So I'm going to use the convolution theorem. The convolution theorem says that if I look at the Fourier transform of G convolved with F, I'm going to write it as F convolved with G. Well, I forget. Wait, no, yeah, this is the right way I want to do it. It doesn't matter. It's the same way either way, right? If I look at the Fourier transform of this is just equal to the Fourier transform of G times the Fourier transform of F. And that's exactly the format that I have here. Like this right here, if I just look at this part right there, that's the Fourier transform of G times this. And I know what the inverse Fourier transform of that is. Using this, we've got, so now I'm going to do the inverse Fourier transform, u of xt. Well, again, as far as Fourier transforms are concerned, this is a constant, the 1 over the square root of 4 pi t. That's a constant. And so now I'm going to do the convolution of g and f. So this is going to be minus infinity to infinity. Okay, so what is g of x? I'm just going to write this as g of x for now. And then times the doing convolution with the inverse Fourier transform of that part. So it's going to be times e to the minus x minus y squared, actually needs to be fraction, over 4t dy. Okay, so let me compile that to make sure that I got everything. Yeah, okay, so this is what we have here. Again, the 1 over the square root of 4 pi t times this exponential. That's the fundamental solution. Okay, but what is, now I'm actually going to use what g is. So what is g? Well, g is going to be equal to 2 as the absolute value of x is less than 1. So it's going to be 2 from minus 1 to 1, and it's 0 everywhere else. So this is just going to be equal to, I'm just going to copy this down because I'm going to reuse most of it. My bounds now are going to go from minus 1 to 1. my g of x is equal to 2. So let me recompile that and see what I get. So yeah, so my g of x is equal to 2. But really, the 2 is a constant, so I can pull that out. So I can pull it out like this. Okay, and then if we want to, well, actually, that's exactly how I'm going to leave it. So this is what it is. We really can't do a lot more with this particular problem because integrating this exponential like that is not something that we can do because it doesn't have a what am I trying to say here? It doesn't have an elementary antiderivative. We can't anti-differentiate it like we normally would. So this is basically where we have to stop at this point, but this is the first solution. Again, maybe a little bit weird me typing and talking, but hopefully it helps some. And if not, just look at this part.